I'm Rubina Shaikh. I'm a postdoctoral researcher in Department of Applied Physics, University of Eastern Finland. I joined Miracle Project in 2018. The role of our group in the Miracle Project was sample collection, ethical clearance and ethical approval, and collecting the data for the experiments ex vivo, in vivo using Miracle device. Regarding the sample collections, we have done the preliminary experiments with bovine samples where we have simulated the different cartilage damages and measure the data from that. After that, we also were involved in collecting the samples from equine and the human samples. Human cadaver samples were collected from Kuopio University Hospital. But one of the problems with the samples were from the old people. And that's why the cartilage was not good. That's why biobank samples were also included in the study. And that's where we were involved in preparing the samples for the experiments. In such kind of projects like Miracle, where there are the involvement of human samples, ethical permissions and ethical issues are very important. And this was a very important aspect which was taken care by our group. Our group was involved in preparing all the ethical related issues like ethical protocol, ethical consent, informed consent sheets for the researchers and for the research. For this project, our task along with University of Oulu was to determine the best parameters for this Miracle device, such as finding the optimal wavelength for the device as well as size and shape of the probe which could be used in future in arthroscopic use. For the Miracle project, the first experiments we conducted was using the bovine samples, that is like a fresh healthy bovine samples from the supermarket, and then we simulated the damages like mechanical damage and enzymatic damage, and then these damages was measured with the Miracle device to find the optimal parameters. During Miracle project, we also provided different reference measurements such as digital densitometry and polarized light microscopy and biomechanical properties of the tissue, which was used to prepare the models using Miracle device. Simultaneously, along with the Miracle project, we also conducted different measurements using near-infrared and Raman to improve and give the feedback for development of the Miracle device. The results obtained during Miracle project with the preliminary experiments with bovine, equine and even human samples, we did found a promising results that with Miracle device we can differentiate between healthy and damaged tissue. We believe that Miracle device has a future potential for the arthroscopic surgery.